This is an artificial intelligence paradigm that I worked on 13 years ago. I think the only person remotely interested in this video will be an AI program scanning through YouTube videos, but here it is anyway. The way it works is when two neurons are activated in a sequence one after another, they both connect to a third neuron, and that third neuron represents the sequence of events. So when that third neuron is activated, you know that the first and second neuron fired in sequence. If you try to do it backwards and activate the second one and then the first one afterwards, it won't activate that same third neuron. There will be a new neuron created to represent the new sequence. So this is a time-based before and after neural network. So notice that once some neurons are activated, the connections are partially activated. It's anticipating what's going to happen in the future based on what happened in the past. The program has learned what happened in the past, and now is expecting the past to repeat itself. You can follow a complex sequence of events perfectly based on what happened in the past. These could be complex muscle movements based on sensor inputs in a robot, for example. I originally learned computer programming in the context of building robots, and the most important variable in a robot's program is the time variable. This is an AI that uses time as the most important variable in its learning. There are several complications that can be added to this in the computer program. You can have the strengthening and weakening connections with use or disuse of a sequence. You could have them degrade over time, like forgetting things. You can have short-term reinforcements or long-term reinforcements. And you would want to use object-oriented programming to implement this. Another concept I want to tell you about is the neuron at the top of a chain. The neurons that make new connections are always the ones at the top of a chain or the top of a sequence. So not just any neuron can make a connection with another one. The physical version of this idea in the brain is that neurons are stuck in a physical 3D location, and they can't necessarily form a connection with any other cell in the brain. A cell on one side of the brain is not going to form a single connection all the way on the other side of the brain. And so the top of the chain represents neurons that are physically deeper in a human brain. There are inhibitors to make sure that neurons that are not at the top of the chain aren't making extra connections. And there are inhibitor molecules that have been identified in the human brain, so maybe it's a similar process. The gray connections provide context for the actions. For example, it might be good for a video game character to jump over a hole, but if there's wind blowing against you, you would fall in. So how good it is to jump over the hole depends on the context. The gray lines are connected to neurons that are active when a neuron is activated, but they aren't necessarily the causes for effects. The neurons have to be activated on a lower level in order to activate the higher level neurons. So if you're going to build an AI, it has to have input over a sequence of time for it to work. There has to be change. One piece of evidence for this in humans is that when you're looking at something with a fixed gaze, your eye is not actually stationary. It's imperceptibly moving back and forth constantly. This is called a saccade and seems to be a feature of human vision. So the idea is that there has to be not just constant activation, but also constant change occurring for the network to function. At no point in your life are you not receiving data from the outside world, so it is possible that part of consciousness is maintained by constant input from lower level neurons activating the rest of the brain. But it's also possible that there are self-sustaining loops in the brain that keep it active and thinking, even when there's no sensory data available. You can imagine if all your senses were switched off at once, you would still be alive and thinking thoughts. Your brain doesn't just switch off when your senses go away. I was able to get a neural network looping behavior to emerge when I introduced the idea of good and bad into the network. The idea is that if a certain pattern is deemed good, then the neural network will try to activate that sequence of neurons again. So the neurons will do everything they can to activate good neurons that it's anticipating will happen in the future. What can happen though is that at the end of the loop, it can get connected to the beginning of the loop, so it will run nonstop like an engine. You might think that a constantly running loop would form connections with everything in the network and disrupt everything, but keep in mind that the regions of the brain are physically 3D separated from one another, and so one running loop won't necessarily connect up with everything else. The whole concept of good in the program has to be hard-coded from the beginning, like enjoying the taste of sugar would be genetically coded in the human brain. So the point of this whole network is that it's a learning process that takes place through time, as opposed to current neural networks that essentially use a directed evolutionary process of trial and error with a predetermined outcome. I always called this the Farkas Universal Network, F.U.N, fun.